Okay, so hopefully you watched the previous video that described, or that basically I was talking about how in the 13th edition, the 13.3 is a bit of a mess up when it comes to this section here. Okay, but okay, so this video we're going to try to go through 13.3. Okay, so what's happening here is we've got this truck. Okay, and this truck is towing two, what do they call it here? Carts, B and C, two carts. It's towing it. There's this rigid little beam here that's attached and between A and B, between B and C. Okay, so what do you notice here? It is a system of particles, a system of particles. So I really encourage you to please go and watch that, not the previous one, but the one before, where I describe exactly how to work with a system of particles, okay? I describe what is the external forces, what are internal forces, and what is the mass of the system. Okay, so please go and have a look at that video, all right? So we've got a system here, and this system is interconnected via these beams, okay? These rigid, what do they call it? I don't think they call it anything. Coupling, there it is. Coupling, okay, so there's a coupling, there's a coupling. All right, okay, so what's happening here is that there's this truck with the two carts, and there is a force based on friction that is being applied to the truck here at the wheels. I'm not going to go into all the details of how that is formed, but essentially we have the force that is causing this system to move, to accelerate, is this FA, and it's given by this. Okay, so it's the baggage truck A, shown in the photo, has a mass of 450. Okay, so that is 450, and tows a 275. There's 275 cart B and 160 kilogram cart C. So there's A, there's B, and there's C. All right? For a short time, the driving frictional force developed at the wheels of the truck is FA equals 200 T. So it's a function of time. So there's this frictional force developed at the wheels. That is the force that is causing this whole system to accelerate. All right? If the truck starts from rest, determine its speed in 2 seconds. Okay, so we need to find speed information at a certain time. So that's question 1. Determine its speed in 2 seconds. Also, what is the horizontal force? Here's question 2. What is the horizontal force acting on the coupling between the truck and cart B? Okay, so what's the force there between these two, between the car and the cart, the truck and the cart? Okay, so there's 2 questions. And so what are we going to do? How are we going to solve this? We are used to a single particle, but now we've got 3 particles in our system. We have a system. So remember what we said in the previous video is that we need to determine, okay, we've got this now. Sum of the forces is mass times acceleration. Okay, that's straightforward enough. But what did this refer to and what did that refer to? What does the sum of the forces refer to and what does the mass refer to? Okay, well, this refers to the external forces relative to our system. The forces that are external to the system. And this is the mass of our system. That's very important. So, guys, again, I'm going to repeat. The forces here in this equation refer to the forces that are external to the system, and this refers to the mass of the system. Now, the question is, what is our system? Well, we want to determine the speed of the truck in 2 seconds. So let us choose this entire thing as our system. We choose that entire, all 3 particles as our system. Okay, so then what does our equation of motion become? sum of the forces in the X equals mass times acceleration. This is the only force that's external to the system. Okay? If we take this as our system, the only force that's external is this FA. You can see that you've got internal forces here between A and B and between B and C, but they are internal to the system, meaning they will cancel out. Okay? They will cancel out. And because we are moving in the horizontal direction, we are not really so interested in these vertical forces. Okay? So we're only going to look in the X direction. We have 200T. That is the only external force to the system. Okay? I really hope you get that. Then what about M? M is the mass of the system. So the mass of the system is 450 plus 275 plus 160. That's what we have there. And that's the acceleration of the system, which we don't know yet. Then if we solve this, we get A as a function of time. Okay? So we're looking for what is the speed in 2 seconds. So we had force information. We used the force information to get our acceleration information. So now we've got A as a function of time. So A is a function of time. Okay? And we are looking for speed. So we've got A, we have T, and we have V. So we know that A is dV dt. Okay, this is old stuff now. And that equals 0.226 T. So we separate variables and we integrate. I'm not going to go over that. And we calculate V. The velocity at 2 seconds is 0.452 meters per second. Okay? But the important thing that I want you to pick up here is when we have a system, there's our equation of motion. We first need to define our system. We defined that as our system, which included all the particles. Okay? And then we need to determine what is external, what are the forces external to the system. As you can see, all these forces are external, but because we're going in the horizontal direction, we only are concerned with this external force, FA, which is there. And then what is the mass? It's the mass of the entire system. And then we solve for A, and we can use kinematic equations to solve the rest of the problem. Now, that's the part A. Part B says, now what is the horizontal force acting on the coupling? What is this now? Okay. Now, we need to redefine our system. What is our new system? We are looking for the force between A and B, this coupling. So we need to redefine our system. Redefine our system. Our new system is just going to be this first particle. Because why? Because when we redefine that, we get this force, and we expose, so to speak, the force between these two particles. So there we go. There's our new system. And when we have a system, we need to do our free body diagram, draw our free body diagram. We've still got FA, we've got normal, we've got mg, and then, this is important, that force, this force here, which was internal over here, remember we had these two forces acting on each other. These were internal in this system, they were internal. Now, when I isolate just this one particle, that former internal force becomes external. Okay? It becomes an external force. I hope you pick this up. So again, there's my equation of motion. This on the left-hand side refers to the external forces acting on the system. So I've chosen left as positive. So what do I have here? Again, I've got 200T. That is that first force, that frictional force, which is actually moving the whole system. But now I need to subtract t. I've got FA minus t because I'm looking at my new system. So I've got, this is my, that was my FA minus t, because t is now there. And what is my new system? The mass of my new system? It's just 450, right? What is my system? It's just that. What is the mass of my system? It is just that. And then times A, which is 0.226 t, and t is 2, right? We calculated that there. So what you need to see now is, as well, is that the acceleration of the entire system was calculated to be this, okay? Which means that each of these particles, each of these particles has the same acceleration, okay? All right, so we've got our new equation of motion, we've got our new forces, which are the forces that are external to the system, the mass of our new system, and the acceleration stays the same, and we calculate t equal to 197, okay? And just for your own exercise, it says here, try and obtain the same result by considering a free body diagram of carts B and C as a single system. Okay, guys, so I hope this helps. Yeah, I hope this helps. And if you have any questions, remember to email me. Cheers, guys. Bye.